All right, so today we're going to do trapezoids and kites. So this page looks like a bunch of vocabulary, so it's not too bad. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides of a trapezoid are called the bases. So here's your parallel sides, and there are your bases. The non-parallel sides are called your legs. So these are your legs. The pairs of angles with their vertices at the end points of the same base are called base angles. So these are your base angles here. Okay. Your legs of your trapezoid are the non-parallel sides of a trapezoid. I think we already said that, but here we go again. Trapezoid is a fun word. So this is what you really need to know, that angle T and P are supplementary. So these two, make these different, equal 180 degrees. And the same thing as R and A. Okay. An isosceles trapezoid means these two sides or legs are congruent. So your legs are congruent. Both pairs of your base angles are congruent here. So that means those would be congruent. And the diagonals are congruent. So your diagonals are congruent. Zoom, zoom. So these would be congruent as well. This is saying everything we just said. So if a trapezoid is an isosceles, then each pair of base and its angles are congruent. So here it's saying that these two are congruent and then these two are congruent. And of course we know that these two are supplementary. If a trapezoid has one pair of congruent congruent base angles, then it's an isosceles trapezoid. So what it's saying then is if you have just one pair, that means it's an isosceles. Basically, this kind of goes with that side, this goes with that side. So since these are the same, then these sides would be the same. A trapezoid is isosceles if and only if its diagonals are congruent. So these diagonals again are congruent. So you have this isosceles, therefore diagonals are congruent. Okay. Now we get to midsection. Mid-segment of a trapezoid. And let's see here. I want to change this because it's a formula. So I want you to go ahead and kind of outline that. And this is a mid-segment formula. Mid-segment formula. And really it is 1/2 is equal to base 1 plus base 2. So they're using AF because those are the bases, but this really is the formula. All right. A kite. A kite is a quadrilateral with two distinct pairs of adjacent, I'm going to say consecutive, congruent sides. So this one, then this one. This one, then this one. These opposite angles are also congruent. Okay. If a quadrilateral is a kite, then its diagonals are perpendicular. So that's huge. So these are perpendicular. So it's a kite. We have that perpendicularity, which means we're doing like a Pythagorean theorem situation to find a missing value of this B, center, C, or something. Sign of perpendicularity. Next, if a quadrilateral is a kite, then exactly one pair of opposite. So it's one pair, not both pairs. So here is your pair. these are going to be different than each other. So if I put this, and then I literally could put 3 there. Okay. Next. Okay, so we're trying to solve this little basket thing. So each side of the basket is shown is an isosceles. So the sides or your legs are isosceles. That means that this angle and this angle are congruent. So JML is 130. So I'll put that as 130. K to N is 6.7. L to N is 3.6. Well, if this is 6.7, then this part has to be 6.7. And this part has to be 3.6. Right there. Okay. Find M, J, K. So we know that these two equal how much? Hopefully you said 180. So it would just be 180 minus 130 would give me 50. That one was easy. Hallelujah. Here we go. Same thing here, right? Same information. No, did they change it? Yes, doggone it. Okay, so K to N is still 6 to 7. Oh, this whole thing of JL is 10.3. This whole thing is 10.3. So how are we going to find that little M to N? Well, obviously we already said that this is 3.6, so it's 3.6. But you could say that that whole JL is 10.3, and then you would subtract that 6.7, and you still get the 3.6. All right. Again, thank heavens we're labeling this because that made that a whole lot easier. Go ahead and graph these two. Okay, so, and label. Okay, so how can we verify that it's a trapezoid? So to make sure it's a trapezoid, you need to have one set of parallel sides. So what are you thinking are parallel sides? This side and this side, right? Those would be your parallels. So let's check this Pythagorean theorem here. So we go up 1, 2, over 1, 2, 3, 4, 5, 6, 7, 8. 2, 8. Up 2 over 8. This one is up 1 over 1, 2, 3, 4. I should have labeled these. B to A. C to D. Actually, we are using slope on this one. This simplifies to 1/4. Are they the same? Yes. Okay. So same slope. Is this an isosceles? So to make sure it's an isosceles, these two would have to be the same. So to be the same, I am going to use the Pythagorean theorem. They keep saying distance. If you're new to me, I'm the Pythagorean theorem queen. So from B to C, I'm going up 1, 2, 3, 4, and 1. 4 squared plus 1 squared is going to give me whatever that answer is. So what is that? 16 plus 1 is 17, so the square root is 17. From A to D, we're going up 1, 2, 3, 1, 2, 3. So 3 squared plus 3 squared. So what's 9 plus 9? 18. So these are not equal. So this actually is a no. BC is not equal to AD. That's kind of fun. We've never had a no. Okay, so that mid-segment formula. So it's I always say A. It's 1/2 base 1 plus base 2. Okay, so here's my bases. I don't have my original base here. So 1/2, what is base 1? We could do X. Base 2 would be K, which is KF, which is 20. And that's going to equal that midpoint, which is 30. Okay, distribute. 30 is equal to 1/2 X. What's half of 20? Plus 10 minus 20 is equal to 1/2 X times 2 over 1 to get rid of the fraction times 2 over 1 to get rid of a fraction, multiply by its reciprocal. 40 equals X. So this was 40. Sorry you didn't get to see that last part. All right, these two here. Okay, so we have this kite, opposite angles, so we're going to say this is 121. I know you're tempted to say this is 73, but it's not, because it's one pair. Not two pairs, one pair on a kite. Okay, so now we know that a quadrilateral is equal to 360 degrees, the interior angles. And so we're going to take 360 minus 121 minus 121 minus 73, and that equals 45 degrees. Okay. This also is a kite. And knowing a kite, we know that our diagonals are perpendicular. So perpendicular diagonals. Okay, so find NP. So I need to find this side. So if this is 6, this is 8. Do we have this one here? This one's going to be 8 as well. I don't think this was labeled correctly. So I'm going to mark these two. Okay, I just don't think it had this label. So to find this missing side, I have 2 legs of my right triangle. Therefore, I can use a Pythagorean theorem. So I can do 6 squared plus 8 squared equals c squared. Grab my calculator, which is somewhere. Six squared plus 8 squared equals 100. 100 equals c squared. To solve for c, you can't have a square, so you take the square root. So 10 equals c. So those were pretty easy. Okay, so again, you can watch the next lesson, or you can stop here and do your first assignment, which is a Google form. All right, moving on to the next one for me. Take a break if you need to.